Hello there, this is Group 15 and we are presenting on thermal power plants. When we say thermal power plants, people don't normally focus on thermal power. They'll be like, wow, plants, green plants that produces power. Hmm. But that is not the case. Let us delve more to understand more. Okay, so in this, we need to know the introduction to thermal power plants, types of thermal power plants, plant components and systems, plant efficiency and optimization, environmental considerations. Okay, so the objectives of this course, we have to understand the fundamental principle of thermal power generation, examine the main components of systems of thermal power plants, analyze the thermodynamic cycles and heat transfer, evaluate the factors affecting plant efficiency and emission, explore techniques of improving plant performance and sustainability. Then we apply critical thinking to solve complex problems in thermal power generation. Okay, so let us begin. So what then at all is thermal power plants? Thermal power plants are the most common type of power generating facilities in the world. So this is telling us that we have something that can help us in generating the electricity we need, and it's a thermal power plant. So they generate electricity by converting thermal energy, that is usually the combustion of fuels, into mechanical and then the electrical energy we need. So these thermal power plants, we don't just say it is a thing, but actually the combination of processes that makes up the thermal power plant. So it is reliable, it is flexible, and it can be built on a large scale to meet the growing demand for electricity. You see, we have big companies here that require more electricity. So it is these power plants that can help us. Okay, so I had a picture of a thermal power plant. Yeah. So this is how it is. Yeah. So how does a thermal power plant work? So it first begins with fuel combustion. A fuel has to be burnt in order to generate a steam. So we can use coal, natural gas, oil. So these fuels are burnt at high pressure and then high in order to generate a high temperature steam. Then this steam that is generated is not too enough because we need the electricity in a large scale. So why don't we use this steam to boil water so that it can generate more steam for us? And that is the next step we go to. So the heat from the combustion process is used to boil water, converting it into high pressure, high temperature steam. Yes, so it's going to produce the large amount of steam we need for the electricity. So they said our boiler design and efficiency are the crucial factors in the plant's overall performance. Yes, so the plant is to generate electricity for us. So it's going to depend on these our boilers that are going to help us to generate the maximum electricity we need. Okay, we then continue with the steam turbine. So after this high steam is generated, it is directed into a steam turbine where it expands and turns the turbine blades. Yes, the steam that it is directed is passed through a channel into the turbine blades, and then these blades are caused to rotate. Yes, so as they are rotating, they generate that electrical energy we need. So it's going to convert the mechanical energy to electrical energy. Then condensation and cooling. After passing through the turbine, the low pressure steam is cooled and condensed back to water. Yeah, so this is a nice process because after the steam has done its work, the low pressure steam is going to condense back into the water, which is telling us that we can recycle and do more and more and more in the production of electricity. Okay, then water recycling. The condensed water is then pumped back into the boiler, completing the steam water cycle, as I said. So we just recycle it to produce more and more and more energy. Okay, so as I was talking about, here is a clear picture of how everything goes. So as the coal is burnt, it is then taken into a boiler container where the water in it is also boiled in order to generate the steam we need. And then these steams are channeled into they are channeled to be taken to a turbine, whereby the blades of the turbines are going to turn. That is why we see an arrow there, which is telling you that it's going to turn. And then as it turns, it's going to generate this electricity. So the steam out is the steam at low pressure that will condense back into the water, and then this whole cycle will repeat itself again. So from chemical energy to heat energy to mechanical energy, then to the electrical energy. Okay, we have types of thermal power plants. We have the coal fire power plants, the ones that use coal for their combustion. We have the natural gas power plants, the ones that use natural gas for their combustion. We also have the oil-fired power plant. They also use that one for their combustion. So they use fuel or diesel as their primary fuel source. So we have advantages of power plants. They are reliable and flexible power generation. You see, you can rely on it because you're going to use it and use it and use it because the water will be converted back. You see, it's a recycling thing. Yeah, and can be built on a large scale to meet increased electricity demands. Yeah, and then relatively low operating cost compared to some renewable sources. Yes, it is. Water is not expensive, right? Yeah. Okay, but everything comes with a disadvantage too. So power plants do have their disadvantage. Significant environmental impact, including greenhouse gas emissions in air pollution. You see, as I said, it generates a lot of heat, and then these heat and then other gases, yeah, it can cause greenhouse effect. Yes, and then it will pollute the environment too. Yeah. Dependence on finite fossil fuel resources. Something like coal, it can get finished. Oil, it can get finished. So these materials, when they are not there, the power plant, it can be difficult for it to work. High initial capital investment for construction. Yeah, the picture I showed you previously, you could see that it depends on a higher capital. You have to have money in order to do all these things. Okay, okay. So as engineers, future developers, what should we do? Increasing focus on improving the efficiency and sustainability of the thermal power plant. Adoption of advanced technologies such as supercritical and ultra supercritical and ultra supercritical boilers to enhance efficiency. So we can develop new ideas, new techniques in order to boost these thermal power plants we use in our everyday life, because we all need electricity, and then companies too need it more. Some factories, they need more electricity. So we have to do things, build up technologies that are going to help in all these things, and then also sustain it. Yes. And then you see, it also pollutes the environment. So we have to have a way integration of carbon capture and storage systems to mitigate emissions. You see, the harmful gases it releases, it's plenty. Yes. So as future engineers like this, we can help solve all these problems. And then besides, we can even consider biomass. Yeah, for all these. This is the end of our presentation, and I'll say thank you.